Good afternoon, class. My name is Suibong Lee, and I got my teammate here, Chun Hong Lim, as well. Today's presentation is going to be water sampler. It is going to take approximately 10 to 12 minutes, and we are open to take questions at the end of this presentation as well. Before we get started, it would be better to have a look at our table of content to give you a better understanding of what going to hear throughout our presentation. Here's our table of content. We go through the project overview of what is the water sampler, why we need water sampler, and the scope of this project, and then we will go through need and specification analysis, minute meetings, mind map, Gantt chart, house of quality, constraint, concept design, final design, 3D drawings, and 3D modeling animation. Um, in this presentation, the setup and the execution of the techniques will be explained and demonstrated as well. All right, let's move on to project overview. What is water sampler? Water sampler are used to collect water sample at specific depth. They can be used in any water body, and the maximum depth is limited to the length of rope you attach to it. It is important to remember that the deeper samples are prone to more drift due to water currents or boat movement. Because of its simple construction, the water sampler is a low-maintenance sampling device. The question is why water sampler is important. The reasons why water sampler is important is water is essential for life, but for many people, the quality water available may be poor. Analysis of water supply may be required to find out whether the water is safe to drink, whether it needs to be treated before consumption. Water sampling is therefore as important as activity as the process of water sampling analysis. That's why we comes up with our design solution to solve this problem. Let's move on to scope of our project. Over the last 3 decades or so, environmental issues have become a significant concern for all society. With growing awareness of environmental issues, for instance, air pollution, global warming, water pollution, excessive use of non-renewable resources, the term sustainability um, has been gaining increasing attention in recent years. That's why we decided to design our water sampling devices based on sustainability standard and the needs of our client provided. Our sustainability our sustainability device allows researchers to collect water at a certain depth with an accurate result. With the portability of water sampler that we offer, it allows researchers to carry them around conveniently from the testing site to the laboratory. As an engineering design team, we prioritize the sustainability and the lightweight of materials used for um, our prototype, which enable users to perform examinations multiple times with its fullest potentials. By design, the water sampler that we provide would be operated manually through an open-close mechanism as for the body of the water sampler itself. It includes a container that can hold water up to 250 millimeters. Additionally, the attached rope has a length of 10 meters with an indications every 1 meters. And here is the need and specification table analysis. The need list that our client provided. On the right hand side, the important level. They want their products to be used in the calm water. They want the products to be portable, can be submerged up to 5 to 10 meters. The volume of the water sampler can hold water up to 250 millimeters, and then the water sampler must be operated manually and lightweight. These are the important ones, like can be used in a calm lake or fresh water. The volume also important, and the lightweight also important. Um, and here's the specification table analysis. We also include the unit and the materials that we chose for um, our mechanisms open close of the container. We chose resins for mechanisms close open and close the container, and we chose natural fiber material for rope. We chose clear polycarbonate for container that can hold up to 250 millimeters of water, and then polyethylene for removable weight at the bottoms of the container. Um, let's move on to meeting minutes. Throughout the entire project period, we have conducted several meetings to plan for our project, to discuss, to make decisions, to finalize um, our design. And I just recorded one to put on the presentation slide today. And our first meeting was conducted on the 2nd of August 2021, and location was on Canvas conference where we normally have our meetings. And then there was only two of us attended at that meetings, and the meeting was all about a discussion over need list, specification, Gantt chart, and work breakdown structures. We also recorded our meetings as well on the a week after, the same place, Convoy's conference, and the meeting closed at 7 o'clock. Here's our mind map. Having a mind map in place is very beneficial for our group project, as it gives us directions to get each task done very efficiently within the time frames. We split our mind map into 4 main areas. We want our design to be portable, to be sustainable, and to be lightweight. And the container, make sure that they will be operated manually through open and closed mechanisms that can hold up to 250 millimeters in capacity and removable weight. Place of use, unfortunately, we can't use that in the seas. It can limit it to be used in like a fresh water or a calm water flow. The length of the rope, we equip our water sampler with 10-meter rope with indications on rope every 1 meters. Um, let's move on to the Gantt chart. Here's our Gantt chart of the project. The total duration of this project is 13 weeks, in which we divided tasks for each of our members equally, and tasks are being allocated based on their skills and their preference. As you can see, we started our project on the 26th of July and finished it on the 9th of September. According to the chart, designing work and report take an equal amount of time of 10 days to complete, which is very time consuming because there's a lot of works to be done in that areas. After this one, we move on to work breakdown structures. By having a work breakdown structures in place is very useful as well, as it um, visually define manageable chunk of the project that a team can understand. It helps us to make our project manageable. It also helps us to develop an accurate schedule so that we don't fall behind. We also split that into 5 main areas. There's planning, design work, testing, report, and final submissions. Here's house of the quality. What we consider as important, we would number it it higher, the less important is lower. So we range them from 1 to 5. 5 is the highest and 1 is the lowest, and we compare them with the customer rating and customer requirements. Um, from this point onward, I'll hand over to Chun Hong to discuss more about um, the concept design. Thank you.
All right. Thank you, Suibong. So after the house of quality, we would have the constraints of our project. So for the constraints of our project, we have the time management and 3D modeling design of our project. As we are not well versed into SolidWorks, we are quite limited by the options we can do. And we also have the limit of what the actual water sampler can do. So as mentioned in the previous slides, that it could only be used in a calm body of water, and it has a limit of how deep it can go. Next slide. So after the constraints, you would have the concept design of the water sampler. As you can see, there's 3 alternative designs. We have 2 vertical water sampler and 1 horizontal water sampler. Next slide. The reason why we settled on this final design, which is from the inventor Yoon Sok Jae, that we took inspiration on. You see, it's more efficient than the previous 2 designs. It would eliminate any unnecessary components that would make the water sampler difficult to operate, and it is considered more efficient as well. Next slide. So here's the assembly drawing of our water sampler. We can break down this water sampler into 2 main parts. The first part of the water sampler is a container with a handle on top. With this, we can trigger the mechanism on top of the handle, and we can also wrap the rope around the handle as well. The second part of the water sampler is the 2 caps at the end of the container that seals the water inside. The way the mechanism works is that when the messenger is dropped down the rope until it reaches the handle, it will trigger the caps at the end of the container to close and seal in the water inside. Next slide. Here's the bill of material. Oh, it's not updated. We have the container, the cap, and the pivot cylinders, and they're made out of polycarbonate. The cap is also is made out of polyethylene and silicone as well. And the pivot cylinder is made out of stainless steel. Next slide. Here we have the 3D model of our water sampler, and it is the exploded view as well. Play the video. We would also have a video to clearly explain how the water sampler would work in the right environment. Though the design may differ from the one we did, the mechanism would still work the same way. Open the. I think you need to copy it.
You just can right click and say open.
Okay, so I'm going to show you how to use the horizontal water sampler. So put it on the counter first. So a couple of different parts that are important. So this right here is called the pin, and it's in the channel, and that moves back and forth. You can pull this sidebar out.
And then this is the trigger. So what we want is to get the pin up the channel and back here to set the trigger. So how to do that is you pull on this part right here, and it goes all the way back, and you twist it, and then you keep going back, and then you press it down with your finger. It's a little tricky, one hand. So that's set, that side is set, and then we flip it over and we do the same thing. So now I'll do this side, pull that out, keep pulling, and then use your finger to set it. Okay? So now both triggers are set. The next what we'll do is we'll go to the bathtub, and each of these red lines measures 1 meter, not this part, but the next one, and there are 20 meters total. So this is our messenger here. So what we do is we hold on to the messenger, and we set this into the bathtub. Straight as you can see. And then this line needs to be really taut, which won't be a problem when you actually go outside and take it from the water. And then when we're at the appropriate depth, we just drop the messenger, and that will trigger both ends to close, and we have our water sample. And then in order to get the water out, move the messenger, we just open one side of this, and then we can pour that into our container. And then
I think they'll do. She covered up pretty well on what Chunhong has mentioned earlier. So I have to share my presentation slide back. Oh. Alright, so this is the end of our presentation. Thank you so much everyone for listening. If you guys have any questions, we will try our best to answer. Thank you.
Okay, very good.
Thank you.
Before everyone start asking the question, I just wanted to thank both of you. Saigong, Chong Hong, your legend. If I was an industry owner, I would be pleased to employ both of you as my engineer. So well done. I'm impressed with your performance. I expected this from the level of engagement you had in the class. So this is what a teacher, a lecturer wants to see. I mean, this is my efforts being paid. I feel that now I can relax. One term of working, if I only have 2 students like you in my class, that would make my day. Not saying that everyone else was not good, but this one particularly I really enjoyed, and I feel obliged to thank you personally. Now I give the microphone to everyone in the class, the audience. Please free ask question from these two gentlemen. Okay, so the first question is coming from, all right, questions. Please, we want to hear your questions. No question? All right, I keep, yeah, we have a question from Cloud. Would you take that question, please? Either Saigong or Chonghong. So Cloud is asking what material you're using for the tube.
We're using clear polycarbonates that the level of resistance with the water is quite strong, so that's why we decided to choose polycarbonate rather than any other materials. Thank you.
Okay, very good. Thank you. The question was well taken and answered.